2.2 trig functions of non-acute angles meaning angles that are larger than 90 degrees, right? I guess you could also say negative angles too, right? They're acute just between 0 and 90, so everything else outside of that interval. All right, so first thing we got to talk about are reference angles. So what is a reference angle? All right, it is a positive acute angle made with the x-axis and terminal side of an angle theta. So let's say I put an angle over here in quadrant 2. And that's theta. Let's say it's like 150 degrees or something. The reference angle from here, it says it's a positive acute angle made with the x-axis. So made with the x-axis in the terminal side. It's going to be, this is your reference angle. Every textbook names their reference angles somewhat differently. I use alpha to distinguish that that is a reference angle. So if theta, let's say, is 150 degrees, what is its reference angle? Well, if it's 150 here, you're shy 30 degrees from the 180, which is the 180 is part of the positive x, is part of the x-axis, that is. So that's got to be 30 degrees is alpha, right? Let's say that this right here is 280 degrees. The reference angle is still with the x-axis and that terminal side. So 1 full revolution would have been 360. So we are shy 80 degrees, right? So here's your reference angle, 80 degrees. I should draw my arrow the other way. It doesn't matter really. Drawing it the other way shows the rotation is counterclockwise positive angles. Same with this one. If I have, let's say, one more, let's put it in quadrant 3. Now, all quadrant 1 angles are their own reference angles, right? They're between 0 and 90. So let's say this is 100 and, not 100, let's do 260 degrees. Reference angle would be from here to here. That's alpha. So here's 180. 260, had to add 80 to get to it, right? So that's 80 degrees is the reference angle here. So just make sure the reference angle is always made with the x-axis, never the y-axis, right? and it's always represented as a positive number. So you'll never see a reference angle of negative 30 degrees. No, it's going to be a 30-degree angle. So we're always going to refer back to quadrant 1 angle. All right, so let's find the 6 trig function values. Of 210 degrees. All right. So step 1, find the reference angle. You can draw a picture if you wish, it doesn't matter. But you know 210 is in quadrant 3, right? That's 180. To get to 210, you have to add 30 degrees to it, right? So our reference angle is 30 degrees. Now all the 6 trig functions of 30 degrees are going to have those same numbers except our signs, that's IGN, may be positive and negative for our trig function values. And this is where we use the mnemonic. All students take calculus, right? So step 2, determine signs or trig functions of that angle. All students take calculus. So if we're in quadrant 3, the only thing positive there are tangent and cotangent. Everything else negative. Yeah, quadrant 3. Oops. All right, so step 3, down a little bit. All right, for step 3, we're just going to say, I'm going to look at sine of 30 degrees, cosine of 30 degrees, those kinds of things, all those values. And now I just attach the appropriate sign, that's IGN, for 210 degrees. So step 3, values of the reference angles. Let's put trig values. So you don't really have to write out this step, but just for your notes, I'm looking at sine of 30, cosine of 30, tangent 30. We already just did this earlier. 1/2 square root of 3 over 2, square root of 3 over 3. Two secant of 30. 2 square roots of 3 over 3. And then cotangent. Square root of 3. Step 4, copy those values and attach the positive and negatives to those values for 210. So 210 is going to be 1/2 for sine, but negative because we're in quadrant 3. Cosine of 210 is that square root of 3 over 2, but negative. Tangent of 210 is that positive square root of 3 over 3. Cosecant 210 negative 2. Secant 210 negative 2 square roots of 3 over 3. And lastly, cotangent now will be positive square root of 3. That's simple. Just figure out what the reference angle is and then go off of that. Just know what quadrant your original angle is and attach your correct signs. All right, so let's do this. Evaluate the cosine of 120 degrees plus 2 times the sine squared of 60 degrees minus the tangent squared of 30 degrees. So we got 30 degrees, 60 degree. Those are acute angles. Should just have those numbers memorized. If not, we can figure them out. Right? And then the 120, right? We'll figure out its reference angle and work from there and attach the appropriate sign. So 120 right here has a reference angle of 60 degrees, right? So we're just 60 degrees shy from the 180, which is on the x-axis. All right, so if I look cosine, is it positive or negative in quadrant 2? It's negative, huh? All students take calculus students. The only thing there would be sine and cosecant is positive. So everything else is negative. So I'm looking at really a cosine of 60 degrees. It's the same thing as a sine of 30 degrees. I'm looking at it that way too. That's 1/2, right? But negative 1/2 because it's in quadrant 2. Now we have 2 times sine squared. So that means after you get the sine of 60 degrees, we square it. So sine of 60 degrees, square root of 3 over 2, and square it. And then tangent of 30 degrees, we just did 30 degrees. All right, that's square root of 3 over 3. Again, 60 degrees and 30 degrees all are in quadrant 1. All that's positive, right? You don't have to worry about determining if it's positive or negative. And that's all squared. All right, a little bit of just simple arithmetic now. Negative 1/2 plus, we're going to square the parentheses first, then multiply by 2. So the square root of 3, all squared, 3. 2, all squared, 2. Similarly over here, square root of 3, all squared, 3. 3, all squared is 9. Some error I made. This is not a 2 down here. 2 all squared is 4, right? There we go. Negative 1/2 plus 3/2, right? Minus 3/9. So negative 1/2 plus 3/2, 2/2. Hmm? Can't hear you. What?
Isn't it supposed to be 4?
Oh, I rewrote it again. That's a 4. You're right. Thank you. There we go. Oh, no, 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 no. It reduces. It is 3/2. This 2 cancels with this 4. So that 2 cancels with that 4 right there. 3/2. So negative 1/2 plus 3/2 is positive 2/2 minus the 3/9, which is 1 minus 3/9. 9/9 minus 3/9, which is 6/9. Reduce this to 2/3, right? There's our answer. Now, we could have just put all this into the calculator, huh? But I'm not going to see, I know in my calculator, I won't see 2/3. I won't see the fraction. I'm going to see 0.66667 or whatever when it rounds. So you can verify your answers this in the calculator. So put cosine, make sure you're in degree mode. I am. So cosine of 120 plus 2 times sine squared 2 sine. Now, to do squared in here, I'm going to have to square the entire sine of 60. So I'm going to have to go back and insert a parentheses here to square that entire function. I don't want to square 60 degrees. I want to square the sine of 60 degrees. So close that and square it. Minus tangent, same thing. That's minus, plus, minus, parentheses, tangent of 30. Close off 30, close off tangent, square it. And there is my decimal. Now I can change this decimal hitting the math button and change to fraction number 1. And now I see the 2/3. But one other thing is, if it was in terms of radicals, I'm not going to see the radical displayed. Now I can't even change it, the decimal, to a radical. So that's one way just to verify that we do have the right answer when we did it by hand, though. Any questions? Pretty simple, huh? Just find the reference angle, right? And figure out what is the correct sign, positive or negative, for those trig function values.